Okay, so now that we've got a solid foundation in the basics of algebra, we can move on to some linear equations and how we're going to solve them. So we're going to use inverse operations to solve these equations, and these can be thought of as the opposite of an operation. So if we take one example, we take addition. What's the opposite of addition? Subtraction. What's the opposite of subtraction? Addition. So these things, they undo the original operation. So if we take multiplication, the opposite to that is division, and division is multiplication. So if we take a number, we start with a number and we apply some operation. Let's apply plus 5. The inverse of that is going to be minus 5. And so a key takeaway here is when you apply the inverse operation, you get back the original expression. So if we take 7, we add 5, then we take 5 away, we get back to 7. Say if we start with 8, now we're going to divide by 4. What's the inverse to 4, the opposite operation? That's multiplying by 4. And you can see if you go 8 divided by 4, that's 2. We times that by 4, that's going to give us back our original expression 8. So you can see we started with 7, we applied an operation, then we applied the inverse, and we got 7. Same with here, started with 8, applied an operation, then the inverse, and got back the original. So the key takeaway is applying the inverse leaves the original term unchanged. So we want to use these ideas to solve for variables within equations. But first of all, what is an equation? Well, some scales are a really good analogy for what an equation is. It just says it's a statement that shows two algebraic expressions are equal in value. So if we just use circles and squares for now, if I've got 2 yellow circles over there and 2 purple squares over there, currently they both weigh the same. They have different weights individually, but 2 of those and 3 of those, they weigh the same. They're equal in value. Now, if I double the amount of circles on the left-hand side, what do you think is going to happen? It's no longer going to be equal. It's going to be out of whack. So instead, when we double the amount of stuff on this side, we have to double the same amount of stuff on the other side. So now these two things are equal in value. So if we use numbers, let's say we've got 2a on the left and we've got 6 on the right. Currently, these things are equal in value. We don't know what a is, but we know that 2a has the same value as 6. Now, if I apply some operation, let's say divided by 2, for this still to be equal, I have to do the same to both sides. Divide 2 over there. Let's simplify this. 2a divided by 2 is just a, and 6 divided by 2 is just 3. So we get a equals 3. So we started with an expression, an algebraic expression, an equation that was equal, and we didn't know what a is, and by applying some inverse operations, we found what a is. Let's go back to these circles and squares for now. Now, say if I want to add something. Say if I add this green pentagon. Again, for these things to be equal, to be the same in value, I have to add the same thing to the other side. So now they're still equal. Let's convert this to numbers now. Let's say we've got a minus 6 on the left, 8 on the right. These things are equal. We don't know what a is, but we know that those two statements are equal. Let's apply the inverse to minus 6. So we're going to add 6 to both sides. And now if we simplify that, we get a equals 14. So we didn't know what it was before, and we applied some inverses and got that. So we can use these inverse operations to simplify equations and solve for unknown variables. So if we take this question, we're trying to solve for a. We don't know what a is. We want to find what it is. We can apply the inverse operation to all the things that are on the left-hand side of the equation to get rid of them, to isolate A. So which one do we want to get rid of first? Let's maybe try the inverse to -5. And again, because it's an equation, we need to do the both to both sides. So we have A plus B minus 5. Now it's part of the inverse, plus 5. And let's do it the same to both sides. Now we can simplify all this. A plus B minus 5 plus 5 just becomes A plus B. And B plus 10 plus 5 becomes B plus 15. Now let's apply the inverse to plus B. So A plus B, the inverse is minus B. And let's bring the inverse over here as well. B minus B plus 15. So we did the same to both sides. And now we can simplify this. A plus B minus B is just A. B minus B plus 15 is just 15. So now we've solved for A. We've found out what A is just by applying inverse operations to both sides.